Well, thank you and welcome with my great pleasure to this panel on supply chain and security in a critical infrastructure system. Well, I think that if you're talking about critical events, there would be no better times than to talk about it. So feel free to chime in, let's say, with your experience. There will be at the end, of course, something related to for the audience, for you. We will try to make this panel as entertaining as possible. The panel will focus on a number of topics because critical infrastructure are central in our current environment ecosystem, even for the existing of the world as we know it at the moment. Is the backbone of our economy. So any disruption to this infrastructure is going to be highly critical. In the interconnected world that we actually see, the systems are built across multiple organizations and spread across the globe. We need to face challenges that we actually face every day, and we have also some demonstration during these days. I hope that the experts that we invited will help us in guiding us in a discussion which will be entertaining and to gain insight from their experience. So I'm pleased to welcome on stage Mr. Sushit Mishra. Thank you very much. He's a CXO at IAD, and Sushit is the Chief Information Security Officer at Autonomous Intelligent Driving, a fully owned subsidiary of Audi, where he's building from the ground up the security for level 4 autonomous vehicles. He's also very passionate about collaborating with the security community and building solutions to improve the ecosystem at large. Please welcome Mr. Sushit Mishra. Thank you. I would like to also welcome Dr. Farouk Kazi. He received his PhD degree from System Control Engineering of the Indian Institute and Technology in Mumbai in 2009. He is working as a chair at WG3 as a digital architecture cybersecurity of India's Smart Grid Forum. He works in the domain of cybersecurity physical system and security infrastructure security. His research interests include SCADA, infrastructure control system, and operation technology. He's been able to do a lot of research and also to secure project funding in kind support from industry like Siemens, Emerson, L&T, Infotech, and Cisco for testing of the environment and devices and secure physical system in general. Finally, please give an applause for welcome to Dr. Farouk Kazi. And finally, Mr. Manish Tiwari. He has 29 years of work experience, including 25 years in the Indian Navy, where he set up the Information Security and Incident Response Organization. He works on the formulation of policy frameworks, conducts security audits, and product testing. In the last held government appointment, he represented the Indian Navy at all national level government forums on issues related to IT security for the protection of the national critical information infrastructure. In December 2017, he has taken over as Senior VP and Global CXO for Bharti Airtel. Welcome. Welcome, everybody. Thank you. So, I think we may need microphones on stage. Thank you. Can you hear us? Or do you hear me, at least, at the moment? Great. Okay, let's try to have a short... Yep, thank you very much. Yes. Yes, ready.
Are we audible? The back end?
Yeah. Any good here? Good? Great. Well, I just gave a brief introduction of your accomplishments, and I would be very happy if you actually would like to say a few words about yourself in general. What do you think are the current challenges in supply chain security? Of course, we are all experts from different industries, with different expertise and background. It's very interesting for us and for the audience to know your special experiences with that. So, Mr. Manish, thank you.
Thanks a lot. So I think the biggest challenge is that the world is moving too fast. It's moving really, really very fast. And in many ways, I think even getting to cope up with some of the fast changing trends in the industry is itself getting to be a challenge. Now, if you are doing a small research project in an institution, or you are, doing something which is more like a, something to do with social responsibility, it is fine. But if you are implementing any technology in a large institution, which has its own complexities, it has a multitude of technologies, and where the actual implementation itself could take close to a year, you cannot afford to have slippages in the so-called supply chain related issues of IT. Yep. Because they can have disastrous consequences with respect to your business continuity and your brand, and also it could very seriously impact your safety of your critical infrastructure. And this danger is more for companies which do a lot of in-house development. So if you are doing a lot of in-house development, you have to be very careful, particularly if you're accessing and you're using, and everybody uses, and I think that's the way to go, is use open source, embrace open source, use open source. But when you are using a lot of open source in your solutions, it's extremely important to keep the licensing conditions also, in mind, because it may not really have a technical implication, but it could actually have a legal implication. And by the time you realize it, your system is already up and about, and your business dependency on that has really gone up. Any negativity around that impacts your brand. It impacts, it could even disrupt your operations if there's a court order for you to take it down, and so on and so forth. The second part is the security. Now, I think, I don't need to evangelize to this community. The very fact that we are at NullCon, it implies that, we by and large all have a security background. But I'm sure over the last 4 to 5 years in particular, all of you have read and heard or studied innumerable of, many use cases in which very critical applications have found to have bugs because they were very vulnerable, very systematic vulnerabilities. And at times when development is done or specific protocols are developed, they necessarily do not have, they have functionality in mind and probably not security in mind. So in the telecom sector, I don't know how many of you have heard, the SS7 vulnerability is really, really scary. Or even in SCADA systems, the earlier SCADA systems, and I'm sure Farooq will speak more about that. I mean, they were not built, protocols used on there were not built for security at all. So you've got to be very careful, because your supply, that could really impact the security of your overall critical infrastructure. Thank you.
Definitely not. I find everything very, very much agreeable. But by the way, just yesterday I spoke about security of end-of-life devices, so we are basically on the same line. Farooq, would you like to add anything else of what you see as a challenge currently nowadays in your view, experience in the supply chain security? Please.
Yeah, sure. So it's a very interesting topic when we talk about supply chain for critical infrastructure. So before I actually talk about challenge, let me first tell you how it is different as compared to usual IT supply chain, the protocols and standards that we follow. Now, when we talk about critical infrastructure, these are those on which many other infrastructure depend. For example, energy is one critical infrastructure, because if the energy sector goes down, there may be many other sectors which will also go down. For example, telecommunication, manufacturing, etc. So basically, critical infrastructures are those on which there is some kind of dependency of other infrastructure. So NIST has identified some 18 sectors which are identified as a critical infrastructure. More or less at home in India, NCIPC has also identified certain critical infrastructures. So one unique feature when we actually try to think in terms of supply chain for this critical infrastructure is that these critical infrastructures are with the time horizon of 20 years to 50 years. That is the most important part when we actually try to look into supply chain contamination. Because if something looks very secure at this point of time, maybe after 30 years or so, when you look at that horizon, when your energy plant or your nuclear installation is supposed to run, it may no longer be secure in that time horizon. Just to give you one example, we all know that this heartbleed vulnerability, when it came 2014 or so, before that, everybody used to rely heavily on this OpenSSL and TLS, etc. protocols. So just imagine a situation wherein a critical infrastructure plant, which is supposed to run for 30 years, and you suddenly understand that this particular vulnerability has emerged. Obviously, as far as supply chain is concerned, you would have taken utmost care to make everything secure of that particular time instant. But if vulnerability comes, the next reaction will be to go for patch management. And this is the very crucial part when we talk about critical infrastructure, because patch management is not that easy in case of critical infrastructure. Particularly when you are working in a live environment, OT environment, patch management will be a very tough task. So I feel the challenges for supply chain as reference to critical infrastructure, number one will be time horizon, where you need to think about 20 to 50 years. Number two, patch management will not be that easy in case of critical infrastructure. And the third and most important part is the availability aspect of this. So typically supply chain is viewed from a reliability perspective, rather than from the security perspective. So many standard actually classify supply chain into different type of philosophies. So usually contingency plan is decided in case of any kind of contamination for supply chain. And as far as that contingency plan is concerned, you need to have some kind of backup to be present. Now that poses a very grave concern in case of critical infrastructure. So there are a couple of unique challenges when we talk about critical infrastructure, when you want to implement the supply chain management as compared to very pure IT. Secondly, all this critical infrastructure are having cyber physical nature. For example, they are not 100% IT. There is some OT or operational technology involvement which is also available. Typically, when we talk about industrial control system where PLC, SCADA, etc., those things are there. So there the supply chain play very crucial part. Let me quote one interesting example with respect to supply chain for this critical infrastructure. Recently, there was a book released by one of the advisor of then President of United States, Mr. Reagan, based upon his experience of Cold War era. And what that book quotes is very interesting thing which was done by US. So then the great Soviet Union was trying to create a trans-Siberian oil gas, and supposedly CIA tricked to purchase a SCADA system which had a backdrop installed in it. And there was a huge explosion which happened in 1980s about that trans-Siberian gas pipeline. The fire was so huge that it was even seen from the space. So when you talk about supply chain contamination in the OT environment, the SCADA vendor, the PLC vendor, the RTU vendor, and all those operational technology component vendors play a very crucial part. And we never know actually where the contamination has taken place. So although for IT industry, this is very well matured kind of area, whereas for critical infrastructure where OT is the significant part, this is really a grave concern, and many people are trying to address it, which we will anyway eventually discuss as we proceed further for our discussion.
Yeah, thank you. That is definitely an aspect that we need to consider, of course. Sushit, would you like to add your own experience and what you see?
Yeah, I think fairly covered most of the ground, but I could just summarize real quick, like the top three things, right? I think one is, to everybody, the panelists said, software is eating the world, right? There's software in every part of our life, right? Whether it's a pacemaker in your heart, whether it's a nuclear reactor, it's a SCADA, it's your e-commerce website, software. And we know it's very hard to secure software. Yeah. No matter how many trainings we do, there's going to be a human element. Developers are going to make mistakes. There's going to be a security bug, and it's going to be bad. Right? So that's one. The second thing is data is the new oil, right? It's like all of our world revolves around data, and each and every company is amassing huge amounts of data, right? Whether they like it or not, they have to. Right? Like today, I can get my electricity utilization. The electric meter is talking to the internet, right? And it's getting all that information back to me, right? So that's the other paradigm shift. And the third one with all this is the threat model has completely changed, because you've taken all these antiquated systems which were not designed for the internet, and like your car today or your SCADA systems or whatever, and you're putting them on the internet, and that completely changes the threat model. It was not designed for it. That's like what Manish was saying. The protocols are not set up to be that resilient. So naturally, there's going to be more risk now because of the way it is being laid out, right? And so we need to think about this. So as an industry, I feel now I've been pretty much in tech all along, but the last now few months I've been focusing on automotive. And the thing I'm learning is the security people need to start thinking more along the safety lines, right? We have to figure out how, and safety has done a lot of work, and safety field as a whole, they measure quantifiably what's the number of errors, and is it a 1 to 10 is to minus 7, that level of precision, right? They get to every system, right? And I think as security professionals, we don't care to do that. It's very hard for us to do that, almost impossible probably, which is why we don't do it. But I think we need to move in that direction. That's my thought. Yeah.
Yep. So thank you for your intervention, your perspective. I also would like to challenge you on something that is going to bring us also the next question. So basically, we are seeing that hardware devices have become smarter, smaller, more powerful. So we are delegating to them more smarter decision in a way. And in some industry now, let's say the direct component become exposed towards the internet and so on. So we have a long history of software security. I'm not sure that we actually are able to get it right, even that. There's no claim over there. But it's certain that the software security has been on discussion in the IT for quite a while. We're starting to see some challenges now on a number of things, and we are going to touch that in a moment, on new hardware devices, which introduce completely different nuances. Long time ago, you didn't have any PLC being exposed or any chance to be exposed over the internet, of course, and now we actually have it. The point is that also the industry of manufacturers prepared in order to support you in this kind of battle? Which are the nuances that we actually see due to this kind of new mixture of software complex and hardware being exposed and interconnection, which are fast, and data and all these things? Which are the nuances that you actually see in your domain? Look at this.
So at least I can, again, so Christopher, this is not something new.
No.
And this problem was there, is there, and is going to remain there, unfortunately. One is the IT industry is extremely fragmented. It's, I would say, largely unregulated. And I'm not, for a minute, I'm not espousing the need to regulate or control, because I feel beyond a certain point that, that takes away the freedom of the creativity. But there are serious issues. And I'll give you an example. When the early SCADA systems came in, right? The SCADA OEMs are different. The base platform on which the SCADA application works is different. And the environment in which they run, which is could be a mixture of specialized devices or typical networking devices, could be a third or a fourth manufacturer. So you can imagine that by and large, even today, if you see SCADA software, most of them are running on operating systems which are at least a couple of years older. So I was attending a energy conference 3 years back, and there was a SCADA OEM presenting their latest version of the software, and and the latest version of the software had been developed on one older version of a Windows server. Now, my friend spoke about, Farooq spoke about patch management. You can keep patching Windows XP as much as you want. It will never be secure. SMB1 protocol is dead. It's insecure, as simple as that. So there's nothing you can do to fix it. And how do you protect systems which are using antiquated protocols or are running on such end-of-life systems? There's nothing you can do other than pray to God and probably restrict it restrict access or put it in a, in a separate virtualized environment or a VLAN or, and say, hey, I'll create an air gap. And we all know there's nothing called an air gap. So I think that is one key challenge. Another example I would like to give you is there was a very critical communication system. I will not refer to which organization, a very critical communication system, which, and I'm talking about the early, somewhere around 2000, right? It would run only on Windows 2000 potential. Now, Windows 2000 ended its life with Service Pack 4. This could not run even if you applied Service Pack 1. So for the entire duration of its very critical life cycle, doing a very critical task, it ended its life as a Windows 2000 zero pack. The only way to protect that was to put it in a separate in an air gapped environment, which used to occasionally fail. So now the last part that you talked about, hardware and software. Now, what you're basically referring, what we are seeing is this new age of IoT devices. And we had, I think it was 2 years ago, where ISP in the US, I'm forgetting the name, was taken down by its own IoT devices. And these are of Chinese make, nothing against China. But I'm saying these were Chinese made devices which had no security built into them. So they got compromised, and these devices turned on their own ISP and brought the entire ISP down. So if you're talking about, if you're talking about hardware and software, I think the next explosion of IT security concerns is going to happen in the IoT space. And whilst the world is aware of it, and I think there is a lot which is being done, I personally feel that it is still not enough. So you have to look at a built-in security as against a bolt-on security, because these IoT devices are supposed to be cheap, they're supposed to be efficient, they're supposed to be deployed in very large volumes. And you have to look at securing these devices. If you try securing these devices and these technologies with the traditional mindset, well, we are destined to fail even before we begin.
Definitely. One small note that everybody are being told that we should keep our microphones quite closer, because otherwise they cannot hear us. Okay. So please, Farooq, what's your view on this new this contamination that we are seeing increasing, and the kind of challenges we just spoke about?
Yeah, so speaking about the challenges for hardware and software, particularly critical infrastructure, one interesting aspect that I would like to bring out here is the most important challenge here is about interoperability of protocols and of devices. Just to give you one small example, for the SCADA system, if some company says that I'm using IEC 61850, the way in which Siemens implement this is altogether different. The way in which ABB will do that will be entirely different. Schneider will configure that in a totally different manner. So interoperability is the biggest challenge when we talk about the critical infrastructure, because most of the time we get multi-vendor, multi-protocol type of devices for hardware as well as for software. And that becomes really a challenging task in case of this critical infrastructure. So the reason here is because we see SCADA as one product, because that's what is like we are tuned to. However, that is not the case. The reason is when we talk about SCADA, it is having the devices, it is having protocol, it is also having stack of the protocol. So sometimes what happens is, although protocol remains same, the stack of the protocol might have been purchased from some third-party vendor, and that may not at all be compatible as such. So when we talk about the terminology in case of critical infrastructure, we need to really look into that what kind of component is actually brought from the third-party vendor, or maybe even many cases, a fourth-party vendor or even fifth-party vendor as well. So I think the challenging part is in terms of interoperability for hardware and software when we talk about critical infrastructure.
Yep, thank you. Sushit, how does it look like in your angle of the world? I assume that basically we are going towards autonomous driving, which you actually know quite a bit. That may become some sort of critical infrastructure as well at some point, especially if we don't drive anymore. So this will become we go from something that we own to something that we use, and that may become critical infrastructure. So at that point, it might be a bit too late, maybe to consider the fact that you have more than 100 DCU that become incredibly smarter in your car. So what's your view on this?
No, you're absolutely spot on. So AVs are, of course, maybe sound futuristic today, but 5-10 years from now will very likely become a reality, right? And at that point, it will be a critical infrastructure, and it could cause a lot of harm to people if not managed from a security and safety standpoint. So I'm, again, a big fan of open source and collaboration across industry, right? I mean, I think, and when it comes to security, I think there is very little collaboration, unfortunately, in the industry. Many people try to play it. Maybe this is because of the legal framework or whatever that may be, and people don't share a lot of the information, right? I mean, for example, there's companies like Google, Facebook, who have armies of top security talent, whereas the Honeywells and others of the world may not have that access, right? And there is a huge disparity, right? But if they all come together collectively, they can have the brain power to actually come up with security standards or solutions that can be applied across the industry, right? And we can hopefully get to an even playing field, because right now it all feels like only the big people who can spend the billions can manage the security well, and the rest are just left to die. And that's not going to help, right, overall.
Definitely no. Thank you for this. So if I understand, you're saying that open source may actually help us in a number of collaboratively use of the intellectual, say, resources that we are all around the world. That's if I see that.
And we look at it like TLS. Yeah. I mean, SSL was broken for quite some time, but now you look at TLS 1.3. Yeah. It's so much more robust and so much more secure because people like Google, Facebook are adopting it and investing time, energy, resources in making that secure.
Yeah. On the other hand, of course, there might be concern for the use of open source product, which Manish instead was, I think, in a way, paying attention. Do you like to add something here?
No, I actually agree completely with him. Great. And the reason is, and I like to give a different example. Security, the basic fundamental platform for securing systems is use of basically crypto. And it has, I have always firmly believed that publicly available crypto algorithms are far safer than privately developed algos. It's a, I would say, an incorrect belief, and this is, this is my belief, that typical agencies at times push for the development of private crypto systems, and these are typically government agencies, but something which is in the open domain is open to the entire world to have a go at. So can you imagine that anybody and everybody who has the capability to evaluate that piece of code, to evaluate that software, the open source stuff which is available, are already having a look at it. There is no better way to test something. Is it perfect? No, it isn't. But I would say that to say that open source or the use of open source will introduce vulnerability into the ecosystem, I don't think that would be the right statement. Yes, if there are systems which are developed, if there is a code which is developed, and if you are planning to use it over a 15, 20, 25 period life cycle, what is secure today is most unlikely to be secured 15 years from now. I'm saying not likely, I'm saying most unlikely, because everything has a shelf life. Otherwise, we would still be using bullock carts on an expressway.
Definitely. Farooq, would like to add something on your view on this topic, how open source might actually help or not help under different aspects, if you have any perspective on this part, please.
Yeah, so I have slightly contradictory perspective on this cryptology and cryptography part, particularly applied to critical infrastructure. So out of those 18 sectors of critical infrastructure, except one or two, like BFSI, finance, as I told you, many of those are actually cyber physical. And what is the nature of the cyber physical is when I'm having some devices like RTO, PLC, etc., they will not be in a position to support high-end cryptography algorithms as such. The reason is they need to process the signal in millisecond amount of time in the real time. And if you're having very high-end encryption, decryption algorithms, it actually will render them useless because once event occurs within millisecond, as I told you, or even microsecond, we need to operate. Now, what happens in case of this AES, DES, or high-end cryptography algorithm? They are secure, no doubt about this. But my requirement is the latency, which is very much critical in case of this critical infrastructure. So many of those, typically if you see energy, oil and gas, petrochemical, and to some extent manufacturing as well, if you see many of those protocols are plain text protocol itself. Forget about high-end cryptography. There is no cryptography at all. So most of those protocols like DNP3 and other, they are by design, Modbus, etc. They are by design clear text protocol itself because what they are more interested in is their response in the real time. So till now, this critical infrastructure industry has believed, contrary to the popular IT viewpoint, is rather than going for the algorithms which are publicly debated and discussed, they go for proprietary type of algorithms. Because what they want is less overhead in terms of encryption and decryption, and more importance is given to the secrecy of that algorithm. That is because of the latency issues and real-time issue. So when we talk about this BFSI, the information security perspective, yes, we do agree that we should have the algorithms which are publicly open source, debated, etc. However, in case of critical infrastructure, the tendency is more towards going for proprietary algorithms which are having less computational overheads so as to make them more usable in a real-time application.
Which brings exactly beautifully to our next nuance of topic. In general, when we talk about securing devices, products, software or hardware, we'll talk about the certification of the product. But we know that security is a process, regardless if the product is security or hardware or software. We do expect from the manufacturer, we should expect some very clear, let's say, key variables, like how long does it take for you to resolve the vulnerability once you have it? What is your average time to patch? Where is your end of life, which is declared? Or do you actually declare? Do you commit to something? What happens afterwards? So these kind of things are actually metrics which can be applied to vendors, and we more or less we do expect them to happen, even if implicitly. So my question to you that instead of certifying only the products, why don't we start thinking to certify the vendor practices, which instead they should be applied to every product of them? For example, are they developing software? Do they have internal views? Do they have secure SDLC? So this kind of metrics could be used, and we do expect something which is, let's say, a proper behavior as a process of the vendor, while we do certify only on the products and not the vendor. Shouldn't we start thinking something like this? I'm challenging you on this topic here now.
No, you're absolutely right. One thing about standards is that the only way, see, the world has become very small. And I think coronavirus has proven it, the way it's spreading. But jokes apart, the fact is that today, if you see supply chain, you have a product. If you were to take it apart, some parts are made in China, some are in Taiwan. A component of that comes from Vietnam. Maybe some part is being made in India, and God knows, some Africa is also turning out to be a manufacturing hub slowly. I mean, it's just taking off. So how do you enforce this? The only way you can do this if you have standards which are global in nature, which are universally accepted. That itself is a challenge. So, and we know that typically when we talk about standards, you do have domination of a few countries, which is much more than the others, and so on and so forth. And there are commercial interests which basically, go into it. But yes, it's good to have these. It would be really great to have these. And it's very good for the industry, because there are times when you have to choose a technology and you don't know when will the manufacturer or the OEM stop supporting it. Now, if you're talking about critical infrastructure, it takes a very long time to, particularly if it's huge, your implementation, the time for implementation, the effort, the cost of system integration itself is phenomenal. And then your dependency on it. And what if 3 years or 4 years later, and my friend spoke about, usage of that for 15 years or 20 years. Now we know that the IT industry doesn't look at 15 years or 20 years. We don't even know where this industry is going to be 15 years from now. So I think, to be fair, it is a concern which should be addressed in the interest of the consumers. But there are practical challenges even for the OEMs. And I think the middle path is the best way, sort of to achieve that.
Yeah, so I think Manish brought up very important point. Lack of universal standard for supply chain management in case of critical infrastructure. The reason is this industry is working in a fragments or in the silos. Similarly, the standards are also made in the silos, although there is some kind of overlapping. So typically when we talk about critical infrastructure, different sectors have come up with their own standards. For example, for energy, the NERC-CIP is having some standard which actually talks about supply chain management and how to avoid contamination. For industrial control system, industrial automation, IEC 62443 has come up with the standard. And as you rightly pointed out, it's not just important to see whether the product is standardized or complying to a particular standard or not, but more than that, whether the process is also complying to that standard or not. So IEC 62443 talks on the both direction. It talks about the product compliance as well as on the process compliance. There is a uniform, more or less, the preliminary, we can say, standard from NIST 800, which talks about this. For IT point of view, people talk about 27,000 standard related to this. So the industry is actually following different standards for supply chain contamination based upon in which sector, and more than that, in which geography we are located. Like in India too, NCIPC has also come up with some kind of controls and standards related to supply chain contamination for critical infrastructure. So it depends upon the sector in which we are trying to address. It also depends upon geography in which we are actually trying to have these particular installations. But problem is, if I'm having a product which is certified against a particular standard, and if the tender document comes up with something else, then that becomes actually a challenging aspect of it. So there is no uniform standard which talk about this supply chain. And that is, I think, the biggest pain point of the industry as of now.
So my perspective is, I think there's a good deal to learn from the automotive industry here, right? And they come from the safety angle. And if you look at it, they have been following this for quite some years, right? No matter which country you go to, there's always a red light, green light, yellow light. There is a seat belt in the car. You may drive left hand, right hand, but there's a seat belt, there's an airbag. And those are standard things that you have to do, right? And in security, unfortunately, we don't have those markers, if you will, or those things that we can quickly say that if you just follow these, more or less, you're safe or you're secure, right? And I think, and the reason that is because United Nations plays a key role in writing the standards which is universally accepted, right? So like right now they're in the process of coming up with the standard for the over-the-air update, right? Because all cars need to be updated on the software, and there's a new regulation being passed right now, which will become a standard by the end of this year. And I think that, but it's all heavily on, like to a point, on the process side, right? They say, okay, show me how is it that you're actually making this system or process or software secure or safe. So that's the question.
So we are going to need standard for updating standards, basically, in a moment. Okay. So I'm going to leave the questions to the audience, so that please put your question towards our guest. So in the last 10 minutes, we are going then to finish a round and closing round before saying bye to the audience. Thank you very much.
Can we pass the mics? Can we pass the mics here? Yeah.
Use mine.
Good morning to all of you. I'm Niranjan. I just, since we're talking about supply chain management and poisoning the supply chain, I wanted the panelists to talk a little more about the Amazon Web Services poisoning, supply chain poisoning that took place in early 2019, and where the entire hardware which was shipped from China was poisoned with a microchip. And how Amazon could manage to take it under wraps, keep it under wraps and still run his business, and didn't lose any single bit of financial business that it could have actually lost because of this whatever loss due to this supply chain poisoning in its hardware systems.
I think you're referring to the shipment of networking devices which went from China to the US, where
Designed in China, bought from China and put it in the cloud. They had put it into the cloud.
That's right. There was also a case where the Pentagon had found a lot of devices which had supply chain issues, and these were systems which were then taken off. Yes, you're absolutely right. The first and foremost thing is that as every country, and let's talk about our country from a national perspective, we must develop that capability of being able to scrutinize, through random sampling, such items which are coming into the country. Now, I'll just give you an example. For almost 10 to 12 years, Microsoft is all present. I don't think I need to even even explain that. But the fact of the matter is that Microsoft is there in all our critical systems and everything. The complete Microsoft source code was available under the GSP program to Government of India for almost 15 years. And it took a very long time for us to sign the GSP agreement. And I was at that point, I had shifted from the government to Microsoft at that point, and all issues were concerned and they were genuine. It's a non-commercial agreement. But finally, the GSP was signed with CERT India. And under the GSP, Microsoft has given access to Government of India its entire source code of its products. But then what? We have to develop the capability in order to scrutinize, in order to evaluate, in order to review critical components of that entire source code. Similarly, we have organizations like STQC, and I think this is where India can benefit from a public-private partnership with research institutions, with academic institutions, to basically leverage their expertise and build that national capability in evaluating the safety through random sampling of critical products which are coming into the country. There is no other way. Yep.
So,
I have a question.
I have another question.
So,
Sorry. Hi, my name is Matthew. And so I had a question and a comment real quick. One is you guys talked about 62443, which is a great standard, by the way. And I think it's one that, as you think about this in the larger context of both critical infrastructure and frankly, any automation, is you think about 62443 is one of the few standards that speaks to not only the manufacturer, it speaks to the company that installs or integrates it and the owner operator. And so when you think about both critical infrastructure and edge devices, that's a great platforming solution, and it's a great standard to work across multiple industries. For those of you who aren't familiar with it, there's a new group called ISA Global Cybersecurity Alliance, which is to promote that standard and drive that globally across multiple industries. I happen to be one of the founding members of it as well. Question for you, though, is in the context of India's new efforts around the 2020 initiative for cybersecurity, do you foresee supply chain being an important part of that initiative that's in Parliament right now?
So who would like to take the question?
Yeah, so you mentioned about IEC 62443. That's a standard which is coming up in case of this critical infrastructure from ISA, which is improvised with ISA 99. Actually, it is having three parts. One talks about the product compliance testing, another one talks about system. However, there is one limitation as well, that it doesn't talk about the site compliance as usually ISO 27000 talks about. So nowadays, many of those OEMs are actually going for the product compliance testing with ISC 62443. As of now, the list is very short. There is one more problem when we talk about the standard and their compliance. The reason is when we say it is a compliant to ISC 62443, for what particular security level it is complying, nobody quotes about that. So I may be having a product which is compliant to ISC 62443, but that may be at the security level 1 itself and not at the higher security levels. So people need to be made aware, particularly those who are involved in procuring and designing the architecture, about these various standards against which the compliance is being looked after.
Yeah, we have time for one, maybe two questions if you are.
No, it's only one.
Please go ahead, sir. Thank you.
So we talk about cybersecurity, we talk about supply chain management, we talk about anything and everything which is basically going into digital in this world. Now, my question is slightly different. This is required to be transformed, but are we really ready for the next warfare, which is going to be a cyber war? And if it happens, it will be the country which has the capability.
Let me attempt that. I don't think any country in the world can claim to be ready for such circumstances, not even the US. The one thing about IT systems is it's basically interconnected. It has interconnected the world in a very big way. You talk about supply chain. Well, that is what it does. Supply chain, not only just within IT, but supply chain literally in the sense of supply chain. You have systems which are talking to each other across countries, hybrid models, partly cloud, on-prem. If you start shutting down systems, shutting down access to systems, then you basically take away the one factor which is driving the world economy in a very big way. So that is the other side of the impact. And the negative side is that it basically exposes, it increases the surface area of attack for your critical information, for your critical infrastructure. So I guess that's where efforts of national agencies in defining what is critical infrastructure, setting the basic standards for securing the critical infrastructure, putting a process in place where there is a trusted relationship between the government and the industries in the critical infrastructure, and I repeat, trusted relationship, would really, really count for a lot. And at the same time, government policies, because eventually policies are only set by the government, not by the industry. Standards can be of a global nature, but policies, national policies, are the prerogative of the government. Policies must come up in a manner, and they are coming up in that where they are investor friendly, they are business friendly, but at the same time, they keep in mind that cyber threats of such a nature, and they basically help not only protect the critical infrastructure but the citizens of the country as well.
So I'd like to add one thing to what Manish said. I personally feel this requires a concerted effort from the government as well as the industry, right? I mean, look at Israel. Israel has quickly become the cybersecurity nation in the world, right? They've got so many startups that are doing cybersecurity. It's all people from the ex-military who moved to private sector started doing this, right? But they've got the government backing them to innovate and become the best in the world. And same should happen in India. If we consider the government considers cybersecurity as a critical asset, then I think there has to be investment. In the same way, even the VC industry, right? If you look at the venture capitalists, look at how many e-commerce and other companies are getting funded, but look at how many security startups are getting funded. Hardly any, right? So that needs to happen. There has to be huge investment required if you want to become resilient as a nation to be prepared for cyber war. It takes huge amount of investment, right? And that can only happen across these two platforms, I feel.
I think India is in the right direction, that means. I think India is in the right direction, that means.
Thank you. I think we have time for the last question before going back to our guests. Thank you.
Sir, I would like to add on one of the previous questions, sir. The case study of AWS, sir, is very interesting again, and what we can learn actually from that is the model that AWS is running on. And my question is that AWS is having a concept of whitelisting. Basically, the APIs which are used, they will be used for that specific purpose only. So no matter what happens, how you progress ahead in your development and all, but the purpose of the application is very defined. The purpose of that particular task is very defined, sir. So similar concept is there in SCADA. It's very defined. Where all we increase our attack surface, we face problem. That is the major area, sir. So aren't we having a similar model like AWS where the APIs, if a person is an administrator, he can only create he can create and generate keys, but he will not be able to decrypt like that. So,
okay, I have a very simple answer, and probably, Farooq, you might see. When I gave an example, and I didn't give the AWS example, and you're right, you're absolutely right. But what is the problem in many SCADA systems? The SCADA OEMs and the base IT system manufacturers are not in sync. You can run a very secure application even if it's a secure application, but if it is going to run on a system which is not secure, the base platform on which you are running it is not secure, that's it. It's gone. Because eventually, that is what it is. So if you're running it on a 10-year-old or a 5-year-old or 6-year-old end-of-life system, whether Linux or Microsoft or whatever, you can't secure it. That's the point. So security has multiple layers to it. Application may be secure, whatever, but if the platform is not secure, your history.
right.
But I think to just add to that, Amazon, of course, has access to GPU acceleration and a lot of new hardware that they can use. Most of these environments are resource constrained and budget constrained. So they have to completely rehaul their entire infrastructure if they want to support what Amazon does today, right? So that is the biggest difference, I feel, right, where there is a disparity. Yeah.
I'm sure do we have time for, I think we are done with the last question. Last thing, one-liner, only really one-liner, 3 words or even one, they would like to close your contribution with on this panel. If you would have to have one single liner before we say goodbye to our audience.
I think more industry collaboration when it comes to supply chain, I think would be super valuable, and people sharing how they're vetting different vendors and what's the principles they're using. I think that should help everybody get better in this whole ecosystem.
So I feel the depth and defense is the only possible way by which we can secure critical infrastructure, considering so many parameters which are complex in this nature.
Thank you.
Universal standards, robust universal standards, and layered approach to security.
Great. I thank our guests and I thank you all for staying here. And of course, we are available outside for further questions if you'd like to take them. But for the time being, I actually thank you for being with us. Thank you very much.
Thank you.
Thank you.